Right, hello everybody. Let's go for our final session. You won't have to listen to me much more, I promise you. So our keynote for the final session, we're now moving into critical raw materials in sedimentary basins. And our keynote will be Lauri Joosu from the Geological Survey of Estonia, who's going to talk to us about sedimentary phosphorites. Lauri.
Hello, everybody. So this is last session today, so try to be awake. Today's presentation I prepared with two of my good colleagues, Karel and Johannes. And today I'm planning to talk about phosphorites, their resources, reserves, how much we have phosphorus, and why we need this. Then I move on to the sedimentary phosphorite deposits and how they in generally are formed. And lastly, I use opportunity and speak briefly about the Estonian phosphorite deposits and what studies Geological Survey of Estonia is doing on them. I begin with a chart that you have seen many times today already, maybe a slightly different design. And I highlighted here the phosphorus and rare earth elements. Why they both are lighted, I come to in a second. But regarding the phosphate rock, you can see that compared to all the critical raw materials, it has rather high economic importance compared to the supply risk. But I'm not discuss this chart more, as you have been seeing this several times already today. So, but why phosphorus is in these critical raw materials charts and lists? So it is mainly used as a mineral fertilizer. So roughly 85% of European phosphorus consumption is used as a mineral fertilizer. Additional 10% as animal feed, and the last 5% detergents, chemicals, food additives, and recently more and more talks have been about lithium, phosphor, and iron batteries. They are really booming, but considering the tonnage-wise, they likely remain rather small fraction of the total phosphorus consumption. So main phosphorus consumption is as a part of mineral fertilizers. And here you can see a chart where there's on the same chart is human population, that is orange line, and then the blue line is mined phosphate rock. So they go more or less in hand. So the bigger world population, the more phosphate rock has been mined. Now, how much we have phosphate rock? So USA Geological Survey estimates that there is about 300 billion tons of phosphate rock resources and 74 million tons of reserves. Just to put this in terms correct, then the resource is something that has studied geologically enough. We know its tonnage, grade, deposition conditions, and we can assume that with additional studies considering mining, technical studies, environmental studies, we can convert this to the reserves. And reserves are something when these studies have already been done, and they can consider it an economic deposit in current situation, depending on the prices of commodity. Now, the reserves are the part that are well studied. Now we can look how these reserves are divided in between countries. So almost 2/3 of all phosphate reserves are in Morocco, and the other countries are rather small players. And considering the mining capacity of each year, these reserves should last about 300 years. Well, this is current estimates. Now let's move on and let's see where the phosphate is mined. So again, the same pie chart with Morocco, about 50 billion tons of reserves. And now how much phosphate rock is mined each year. So in this chart, the biggest pie slice goes for China, where around 90 million tons of phosphate rock is mined each year. I highlight here that here is the units. Here on the first pie chart, it's billion tons, and on the second, it's a million tons. So there's a huge difference. Following China is Morocco, USA, and Russia. What's also important here that China mainly uses phosphate rock internally. So as Morocco is the major exporter of phosphate rock, so Morocco will affect the global phosphorite market a lot. And what's happening in EU? This is rather boring pie chart. So in EU, there is one active phosphate mine operating in Finland, Siilinjärvi, and producing roughly 1 million tons of phosphate concentrate each year. Now, when we take a look at European phosphate ore deposits, then there's actually quite different charts and information you can find from internet. Here is something that it's collected with this screen project in 2023. So according to this, biggest deposits are in Sweden, where the phosphorus is in form of apatite and is a byproduct of iron mining. Estonia has also very large phosphorite deposits, and the other numbers are much smaller. However, Finland, Greece, and Sweden have reported or studied their phosphorite deposits according to the internationally recognized standards. So this is the overview that there is a quite big phosphorite reserves, but they're at the moment are really concentrated in the few places, and there is very limited mining of phosphate rock in Estonia, in EU. However, there is quite significant potential. So let's move on and talk briefly about how phosphate deposit form. So phosphorite deposit can be igneous or sedimentary origin. However, most economic phosphorite deposits are sedimentary origin, and they make about 95% of the whole phosphorite deposits. In generally, igneous deposits are lower grade, roughly 5 to 15%, but they can produce high grade phosphate concentrate because they are relatively easy to concentrate. Sedimentary phosphate are in generally more rich, but they cannot be beneficiated so high P2O5 levels. And when we look at the sedimentary phosphorates, then vast majority of them are autogenic apatite formed in the upwelling systems. I soon will speak about in more detail about that. And rather small fraction is this biogenic apatite. And Estonian apatite is considered part of that group here. But now let's see how we think that sedimentary autogenic apatite is formed. So, as I already told, these mainly form in these upwelling areas near continental shelves. These are the areas that actually they are a small fraction of the world ocean, covering less than 1%, but are estimated that they account of 5% of global marine primary production. So these are the areas where the where the upwelling currents bring oxygen and nutrient-rich waters up the shelf. The nutrients also coming from the mainland to erosion. They reach into the ocean by rivers. And then we have very reactive bioproduction. So a lot of life, dead organic matter are degraded, and elements are taken again into this biocycle. And in these areas, at the bottom, there is zones where actually it's called oxygen minimal zones. And we see that this is the place where the autogenic apatite is formed. And what actually happens in these sediments? We know that in these sediments, at the boundary of suboxic and sulfidic conditions, live bacteria. They are called large sulfur bacteria. And when conditions are suboxic, then they capture the phosphorus that are released from the organic matter degradation. And when environmental conditions turns to sulfidic, they release this phosphorus into pore water, generating very high concentrations of phosphorus in pore water, and this leads to the precipitation of apatite. And what we can see in the rocks is that small kind of these phosphate nodules form. They can, of course, develop into these layers. And later, when the water levels changes, storm events come in, they are concentrated and can form these really thick, high phosphorus deposits. We also know that phosphorus is a very important nutrient, and in geological timescale, it's usually limiting the bioproduction. So when we look at this timeline here, we can see, that phosphorus, sedimentary phosphorus, are really occurring after Neoproterozoic, and it's forming these kind of distinct peaks. And actually, all the major phosphogenic events can be related to some global wide disruption in life or bioproduction. So, but if we start from the bottom and look at the first bump here, this first sedimentary phosphorites appear around 2 billion years ago. And just after the great oxidation event, the amount of these phosphorite deposits are small. There are no economic deposits at that age. But the forming of first sedimentary phosphorite is related to the appearance of oxygen, and then started heavy oxidation of rocks that are subsurface, and then influx of these elements, including phosphorus, in the world ocean. But if we take a look at the later ones, then the next peak is just after Neoproterozoic oxygen event, when the oxygen levels in atmosphere were more or less similar than today. And the next one here sits actually at the boundary of Cambrian and Ordovician. And in this period, we know that there was a huge mass extinction. A lot of species died. And in this peak is where also sits the Estonian phosphorite, among others. So phosphorite depositions are related or linked with major disruptions in this otherwise usual life. Yeah. But now I don't talk about very much about rare earth elements in phosphorite, because I know that Sophie is doing great presentations about them and going really in detail soon. But I just mentioned here that phosphorus is mainly found in a form of apatite, and apatite is very prone to chemical substitutions. Some substitutions can be beneficial. For example, rare earth elements that can substitute calcium. There are also elements that can substitute similar way that are not so profound, for example, uranium, cadmium. But this, as these elements are easily to concentrate in apatite, the rare earth element concentrations in sedimentary apatite can go up to 2000 ppms. That it's still low compared to the rare earth deposits that are mined today, but still a lot higher than sedimentary rock usually. But now let's move on to the Estonian phosphorite. As I already mentioned, it deposited during the Cambrian and Ordovician boundary. And our phosphorite is actually a sandstone in a mixture of brachopod shells. These are the animals, somewhat similar you can find in the modern beaches, but they made their shells in not calcium carbonate, but calcium phosphate. The phosphorite in Estonia is in generally overlain by black shale, clays, glauconitic sandstone, and then following different depth of limestone. And during the deposition, Estonia was on a southern hemisphere, around the similar latitudes we are right now, so around 60 degrees of latitude, but on the southern hemisphere. And these Estonian phosphorite are likely formed as an ancient beach. So these shells are gathered in a different storm events. And in Estonia, the main phosphorite deposits are concentrated in the northeast Estonia. There are Toolse, Rakvere, and Aseri deposits. And it's estimated that these three deposits have about 2.9 billion tons of phosphate ore, and the Rakvere deposit is surrounded by prospect areas that it's estimated to have another 8.4 billion tons of phosphate ore. Estonian phosphorite have been heavily explored during the 1950s to late 1980s. During that period, more than 4,000 drill holes were drilled and tens of thousands of samples were collected. These explorations ended with a nationwide opposition that Sirli mentioned in the first presentation. For today, we have preserved only very small number of drill cores, and these drill cores are very poor condition. However, what we have is reports from previous explorations in our geological archive. So when the exploration was stopped in the late 1980s, there was basically no systematic phosphorite exploration in 30 years until the establishment of the Geological Survey of Estonia. So what we know more about this from these previous explorations, here is the map of P2O5 grades, and we can see that this is changing a lot. So the highest grade is in the center of Rakvere deposit, where some areas go around 20% of P2O5, and then we can followed by Tools and Aseri deposits. When we take a look at the thickness that it's covered in this color scheme, then roughly the same area in Rakvere is the thickest and going thinner in more north. However, the depth of the deposits, you can see with these green lines, so roughly 20 meters here, 60 meters here, and 100 meters here. So the deposits goes deeper and deeper towards the south. And what we know about the trace elements in phosphorite, we know that they are in general very low compared to the other sedimentary deposits. For example, uranium values are roughly 4 times lower than world average. And here is chart when we use just one deposit, but it more or less goes for also for the other deposits. That basically all elements that are on the yellow box are lower than global average. So there are some that are close, for example, total res and lead, but for example, cadmium is very low in Estonian phosphorites. If we take a look at the rare earth elements, then we can see that in Toolse deposit, we have 300 to 400 milligrams in ore, but we can see that rare earth elements are really in the apatite structure. And this gives us really nice correlations here for Aseri and Toolse deposits. Sorry, I lost my pointer. Anyway, for this chart, good correlation between P2O5 and total rare earth elements shows that for Aseri and Toolse deposits, the rare earth elements are really mainly in the shells, in the apatite structure. But in case of Rakvere deposit, we don't see this correlation between rare earth elements and P2O5, meaning that, of course, some of the rare earth elements are in apatite, but they're also in the other forms. And this leads to that when we start to remove the sand grains from the brachopod shells, we likely don't see this concentration of rare earth elements. And now I would like to talk about a few words about current exploration that Geological Survey is doing in the Estonian phosphorites and has been done in the last few years. So Geological Survey of Estonia was established in 2018, And phosphorite was one of the topics that we start to work quite soon. So the next year went to planning and to get permits for drilling, because we understood that we need to make some new drill holes. The 2020 was the main year when there was exploration drilling that actually ended in 2021. And the 2021 was mainly spent for analysis and modeling. And during that time, we actually digitalized all the data that was drilled in the Soviet time. So several thousands of drill holes that were documented in these paper reports were digitalized in a way that we could prepare a 3D geological model and compare the values of these models to the new drillings. What we also did is that as the phosphorite deposits cover quite large area in Estonia, then we tried to identify the hotspots that we could continue exploration in future. And we prepared let's say, geological report of the results of the new drilling, the modeling based on the historic data, and how do they correlate. And after that, we get governmental funding for the next stage that should end in 2025. And after that is again decision point, if to move forward and how. So depending on the results, there should be, in generally, let's say, 2 steps when the exploration goes more and more detailed. And what is the main goal? Our main goal is to identify the economic potential of phosphorite valorization in the target area while minimizing the environmental impact. So we have located quite a small area, about 10 square kilometers, where we focus on our study and exploration. And actually, as we speak, we do some drilling there. And what's also very important and cool for us is to find economic ways to utilize the associated resources, including rare earth elements, potassium, and others that are associated with phosphorite or in the overlain rock units. So the main takeaways are the phosphorus and rare earth elements are listed as critical raw materials by the EU. At the moment, EU imports around 85% of its phosphorus demand and 100% of rare earth demand. In sedimentary phosphorites, rare earth elements substitute diegenically in apatite structure, meaning that this can potentially be a resource for rare earth elements. However, that said, at the moment, as far as I know, there is a lot of projects similar to us trying to find the way, but there is no active factory commercially producing rare earth elements from sedimentary apatite. Estonia has significant phosphorite deposits containing elevated concentrations of rare earth elements, and we are doing research and exploration projects to gain better understanding its environmental potential and also environmental impact. Thank you.
Thank you, Lauri. Do we have some questions? While everyone's thinking, I've got one. I've been to the Moroccan phosphorite deposits, and they're very white, they're very clean, which looks quite different to your photograph. Have you ever compared, or has anyone compared directly the chemistry of the Estonian and the Moroccan phosphorite deposits? I'm wondering if perhaps the Estonian ones are a bit dirtier, but that also means they're higher in rare earths.
Yes, there has been comparison. I know that, for example, cadmium levels for Morocco are much higher, but I can't say by heart how the rare earth elements really compare towards Estonian and Moroccan phosphorites.
Interesting. In Morocco, there's an entire university financed by the phosphorite deposits. So, yeah, they're doing well out of them. There's a question here.
Well, it's more like a comment. This year there was a press release from the company Lauri Mining claiming that they have uncovering 70 billion tons of phosphate, so basically beating the Moroccan deposits. Do you have any comments on that?
Sorry, what company it was?
Norway Mining.
I'm not sure if this is the same case. I remember one very large deposit from Norway, which I read it from the newspaper. I tried to actually contact the firm because on the firm or the company homepage there was order of magnitude smaller numbers based on York, and I didn't got any answers. But maybe you can.
As a Norwegian, I can comment on this. This is a Horax message, or it's actually the rock exists, but the phosphate content is very low. It's about 3-4%. The deposit has been known since 2001 and perfectly described. So there is a newcomer on the market. They want to attract investors and claim the whole deposit. It's of course a big intrusion, and if you take the phosphate content in the whole intrusion, you come to this number, but it's not feasible to mine. It's just to attract investors. Yeah.
Okay, it's good to know.
It's like all the world's largest rare earth deposits, of which we've seen many.
Another follow-up question regarding the rare earths, even though there might be more talks on them as you presented. Do you have any normalized profiles or anything of the proportions of the individual rare earth elements?
Presentation. They are middle rare earth enriched.
They are?
Yeah.
Okay.
Past normalized values are middle rare earth enriched.
Okay. Interesting.
So, yeah.
I mean, of course, it affects the relevance of the rare earth elements. Thank you.
We can take a look at the charts later. Or in Wednesday if you are in Arvavere. I don't know.
Not on Wednesday, I'm afraid. But
okay, then we can do it later.
Yeah, thanks.
Any other questions? No. Good. Okay, I think we can move on. Thank you very much, Lauri.